Hi guys, good morning. Welcome back to the new video. And this is although it marks as hard, but if you have been watching our videos, I'll say the name. But if you have been watching our videos, you will just have to try this problem. It's very easy. It's gonna use binary search and BFS, and for short, the intuition is very easy, and still you should be able to apply it. So please by yourself, you should be able to do it if you have been watching it. If you have been watching and understanding our videos regularly, if not, then you are missing something in the old videos which you're not understanding, or you're not taking notes and stuff. Cool. Let's quickly jump to the process. Last day where you can still cross what? Cross the island, right? Cool. It just says that okay, I have a one base binary matrix where 0 means land, 1 means water. Cool. I'm initially on day 0, the entire matrix is a land matrix. Cool. And as a new day comes in, a new cell becomes flooded, which means it becomes a water. Now you want to find the last day it is possible to walk from the top most cells to the bottom cell by only walking on land. For sure, you can only walk on land, right? So that's the reason it just says, okay, what is the last day? Okay, one day, next day, because each day a water is being a land is being flooded with water. So basically one cell is being transformed to a water cell. So what is the last day? It is still possible to reach from any of the top cells to any of the bottom cells. Now, and the movement, it can be a 4-directional cardinal movement which we can have, and we have to return the last day where it is possible to actually move from the top to the bottom cell by only walking on lands. Cool. It's a problem statement. Let's quickly remember the examples. Let's see. There are 90% of the problems in which example gives you the actual intuition of what to think, what not to think. But we actually go by, okay, what is being done, then what actually we are doing, then what we can do. Cool. As you can see, initially in the day 0, before even starting out, we can easily walk from top to bottom initially. From here also it is walkable, so no worries. As 1,1 gets flooded, 1,1 gets flooded, still I can move from top to bottom. Very good. As 2,1 gets flooded, okay, it is flooded, it is also flooded. Again, I can move from top to bottom. As 1,2 gets flooded, now there is no top cell to actually start from itself. So here itself I cannot move at all. Here itself I cannot move. And for sure, as here I cannot move, then going forward itself I cannot move. So it's the last day. Day 2, it's the last day I was actually able to move from top to bottom. So answer is day 2. Now going on to the next day, it's nothing but we start from here. Okay, initially all lands, for sure it's movable. As soon as 1,1 comes in picture, okay, still I am movable. As soon as 1,2 comes in picture, all the starting cells are also always occupied, so it's not movable. So the last day I was able to move was 1,1, which is the first day itself, and that's the answer is 1. Next example, walkable. Cool. 1,2 came in picture, 1,2 still walkable. 2,1 came in picture, still walkable. A 3,3 came in picture, still dated walkable. Which means I just have to start from any of the top cells, reach any of the bottom cells. That's it. 2,2. Ooh, 2,2. I can start from here, but I cannot go anywhere down. I can start from here, but here I am stuck. I was not able to reach the bottommost cell. Sorry. It is not possible. So one thing we could easily see, okay, if we had to see, I'm simply going on to every cell, placing that as water, and then I am trying to go from any of the top cells and trying to reach ultimately any of the bottom cells. So if I just break this problem, I'll say, okay, my one part of the problem is start from the top cells and try to reach the bottom cells by only visiting the water. So only visiting the land and not visiting the water itself. So one problem is, okay, if you have at a particular stage of time, which means, okay, let's say at this point of time when you added 1 water, so now you have 1 water, which means 1 obstacle you have. You can only walk on lands. So you will start from the top cells and ultimately your aim is to reach any of the bottom cells. So you can simply do a graph traversal starting from these nodes and ultimately trying to reach any of the bottom nodes. Also, as soon as the next cell comes in picture, I'll simply make that also water and then again try to do the same stuff, which means start from the top cells, whichever is available, and then try to reach the bottommost cells. Then again, as the new cells comes in picture, I will just simply add that as water and again try to do a graph traversal, which means start from the top cells and try to reach the bottom cells. Now, when I say graph traversal, it is simply either it can be a BFS or DFS, because my ultimate aim is it possible to reach the bottom cell after starting from the top cell? If yes, then it's good. Which means if it is possible to start from the top cells and then reach the bottom cells, then it is good. If it is not possible, then sorry. So one thing I was for sure, no, okay, I will go on to every of these cells. Firstly, this, and then, okay, up till here it was possible. Now, as soon as I tried this, it was not possible. So for sure, going forward also, it's not possible. So last day it was possible was the day number 3. So I'll just say answer as 3. But you know one thing for sure, that you are going on to every cell, marking that cell as water, and then trying to do a simple graph traversal, which is a simple grid traversal. Either it can be by BFS or DFS, and then simply trying to see, okay, starting from the top cells, is it possible to reach the bottom cells or not? Now, as you do a simple graph traversal and we're going on to grid of this whole array of cells, firstly, one thing for sure, I can go on to the whole array of cells, and then for every try, which means for every putting it as water, I have the new grid now. Now, as I have new grid, I will simply do a BFS traversal on that grid, which means again a complexity of BFS-DFS. So as we know in this problem itself, the complexity of my cells is nothing but row into column, and that row into column has the maximum size of 2 into 1e4. So it is 2 into 1e4 for that. So we know, okay, it can have a maximum value of 2 into 1e4. It's the upper bound. But this BFS and DFS, if we consider in a grid, a BFS or a DFS, it tries to visit every cell exactly once, right? It's what is considered as a BFS and DFS. But as you know, it's a 4 directionally connected. So for sure, it will try to visit every cell exactly or at max 4 times. So as it is 4 directionally connected, I can move in 4 directions. So I will try to visit every cell at max 4 times. Now, if I can visit every cell at max 4 times, so I know one thing for sure, okay, it will just be still O of row into column, which means every cell, which means row into column, every cell of this grid matrix, it means row into column. So I can visit it at max 4 times. So it can be 4 into this number, or simply this number itself, because 4 is constant. So it will be 2 into 1e4, which is 4 into 1e8, which is still won't work. Although the complexity will be into 4 itself, but still it also won't work. One thing for sure, what we thought of, it is right. What we thought of, which means the brute force, the standard way, going on to every cell, then making it as, it is right, but it will have a high complexity. We have to optimize that. Now, optimizing it's nothing but looking at the pattern, what the problem is offering you. Is there any pattern which you can find out and you can utilize for you to bring out another data structure or another algorithm to come in picture? So let's see the pattern which we saw earlier also. Now, as we saw, okay, it was possible, which means a traversal was possible. As soon as a 2, 2 came in picture, it was not possible. And then still going forward, it was not possible. So, do you see some pattern in this? Possible, not possible. So basically, something is happening and then it just stopped happening. Something was happening, and then it just stopped happening. So earlier what I was doing is, I was simply going on from the left. Okay, is it happening? Now, can't I do something like this? Okay, just go at mid. Just because, see, earlier I was simply doing a linear search. Now I know one thing for sure, it is something like this. The pattern is something like this: happening, not happening. Now, if I know, okay, it is something like this, then I can try one thing. Maybe I can do a binary search kind of stuff. How? I will simply go and point here. Okay, hey bro, are you a wrong or right? When I say wrong, which means not possible, I'll go ask, hey bro, are you a wrong? If the bro says, bro, I am a wrong, then for sure one thing, the going forward part is also wrong. So the right part is entirely discarded. Now my range will be the left part itself. Now I will ask him, hey bro, are you a right or a wrong? Then again, firstly, my mid was here. Then again my mid will land somewhere here. He will say, okay, let's say mid lands here. He will say, hey bro, are you right or wrong? If he is right, okay, I can update my answer. Okay, this answer can for sure be possible, but it is just a try. Maybe I can improve my answer. So earlier my range was this. Sorry, what was my range? Let's see what was my range. My range was this. So it was a right. Now earlier I can simply say, okay, it is one of the answer which is possible, but I can simply again try to maximize my range. So I will now try for this range. Now I'll again ask him, hey bro, what is your mid? Let's say it points here. So although my answer right now is having this, let's say day 2 is my answer so far, but I know I need to improvise my answer. So I know, okay, I will still try to do a binary search and going forward. Now it is still a wrong, which means I will still have to reduce my range, range reduced. Again, mid landed here, now mid is here. Simply doing, okay, hey bro, what's your mid? Finding out, okay bro, I am this. So a day 3 was updated as the maximum answer. Now by this fashion, by this pattern, okay, it's linearly okay, and then not okay. So by this you can discard. See, whenever you can discard any of the half ranges by any concept, you can simply apply binary search. So I know by this, okay, I know there's a y, yes, no, like x, which means currently like yes, no. So I know, okay, as soon as I point at any location, I can discard other half range. So if I can discard other half range, I can for sure use a binary search here. And earlier I was doing a linear search. I was going on from here to here. Now I am doing a binary search. I know linear search would take O of cells dot size time, but binary search will take O of log of cells dot size time, and that is how you can improvise your complexity, which means binary search you will use. Now you will use binary search and simply reducing your complexity from O of cells dot size to do nothing but O of log of cells dot size, and this log of picture will come in picture. This BFS still you have to do at any point of time. If you point to any location, which means here you point out, hey bro, is this as a valid? So what you will do is, you know, okay, it is the mid. You will try to go and place all these. You will try to go and place for this particular mid. You will try to go and place all these cells as water in your grid, and then check, hey bro, is it possible to reach from top to bottom? If it is, it's okay. If it is not, then for sure this mid is not good. And how many times this mid will come in picture? This mid will come in picture O of log of cells sort size times. This mid will come in picture, and as it comes in picture, for every of such O of log of cells or time, what you will do is you will go and put in all these cells as water, which will take again O of cells time, plus then you will do a BFS or DFS, which means O of BFS or O of DFS, which is nothing but O of rows into columns. That is how this factor, the factor right here, this factor into this factor will actually be your final complexity. Let's quickly jump and see, okay, what we mean by binary search and how it is being done. Although it's very standard, very simple. Simply you will have a left, you have a right, and how left and right are being chosen. Simply, you know your answer. It can be a simple from day 1 to actually day XYZ. Now, simply considering, okay, day 1, if your cell is being added, what is actually the possibility? Now, I just say, okay, I will start from A1 and ultimately I can go up till cells dot size. Now, again, as you find the mid, you will see that ultimately your options will be for this particular array. If you are choosing for day 1 and you can, like, why it is 1 and 0, see, if the answer was 2, like, it's just say, sorry, here the answer was 1, which means, okay, it was actually the index 0, which was possible. So basically I just say, okay, from day 0 to day mid, but mid, when I say, I actually mean a mid -1, because it is indexing based on the basis of my cells. Cool. So it is the reason, because I have to place water on those cells, and thus I'm trying for those cells itself. And ultimately, you know, the complexity will be nothing but O of BFS or DFS. You can apply anything, because ultimately your task is just to traverse the particular grid, and for traversal you can use anything whatsoever you want. So ultimately, you know, it's just for every of those mid locations you have to do an entire BFS or DFS, and thus time will be O of rows into columns and into log of, this is nothing but 2 into 24. I guess it is right, 2 into 24, right? 2 into 1e4, yep, and that will be a log of 2 into 1e4. And that's how you can simply, and space is nothing but using the space of BFS or DFS in the entire grid, which is nothing but either it can be visited, or it can be the grid you are using, or it can be the queue you are using. Now let's quickly jump on to the problem itself. As we know that for sure I will have a left and right as a starting range. I know how many days I have, starting from the left as 1, okay, 1 day, and right as the entire cell dot size, because it is the cell which at every day I am trying a new cell, putting a water at new cell. So it is nothing but right is restricted by cells dot size. Ultimately answer will store my final answer in my actual answer variable. Now ultimately a simple bind search, while left is less than equal to right, simply go and find the mid. Left plus right minus left by 2 simply, or you can also do a left plus right by 2. Just make sure that it does not go out of bounds of the integer limit. Now you will use a can walk or any function. This function will go and check, hey bro, is it possible to actually place my mid, which means mid I am considering, okay, from day 0 to day mid minus 1, I am placing all the cells as water. Now after placing all the cells as water, is it still possible to reach? If it is possible to reach, then I will improve my range to the future range. If it is not possible to reach, then I will restrict my range to the older range. So it is how I can do a binary search with this help of the mid. Now I'll just show you in a meanwhile what this can walk function will do. Is just simply checking if this mid, and mid is nothing but we are trying for a particular day. Okay, it is a maximum day which we are trying for, and we will start the indexing from 0 to up till the mid minus 1. And if it is possible, then for sure I will increase my range, which means okay, my new range will become the more range. So firstly I will have to update my answer with the current mid. Now the new range left will be increased by mid plus 1, and right will remain with the whatsoever right we had. If it is not possible, which means if this is not, if it can't be walkable, then simply reduce your range. Now reducing your range, which means you're reducing your right back to mid minus 1. Reducing your right back to mid minus 1. See, when I'm showing this, I was doing a binary search on from left to right, and left is nothing but 1, right is nothing but mid, right is nothing but cells. Now as I did a mid, my mid will point somewhere here. Now for trying out in actual array of cells, I have to convert it from 0 to mid minus 1, but doing a binary search I'm doing from 1 to mid. So if I'm doing my range modifications, now old range will become from 1 to mid minus 1, new or the right range, it can become from mid plus 1 to actually right. That's the reason I just did, okay, right is nothing but mid minus 1. If it has to come into a like above range, if it has to go to the bottom range, then it has to become a left is equals to mid plus 1. That is how you can do an actual binary search. Now ultimately, as soon as the binary search completes, you can simply return your answer. Now coming on back to the can walk function, which is nothing but simply doing a BFS or a DFS traversal, which one looks fine to you on this entire grid, considering that okay, you have to fill in at, it is nothing but the day. Okay, you just tried for this day. Now for this day, please fill in all these cells, and as I showed you, okay, when I say the day, I am putting in my cells from 0 to that particular thing, right? Now if I say I have 3 days, now it will be from index 0 to index 2, say, right? So if my day at is mid, so I will try to place in all the values from 0 to mid minus 1 from my array cells. So if my day at, which is nothing but the mid, which I'm trying, I will try to place from 0 to day at minus 1 all the cells of this grid as 1, which means water. So I will initialize my grid as entirely land. Okay, it is entirely initialized as land, which means placing the zeros, and then I'm placing a 1 for all the cells from 0 to day at minus 1, because I considered okay the day at as mid, and then the indexing is from 0 base to a 0 to mid minus 1. Now as soon as I have got it, I have to start my queue procedure. Now queue procedure means getting the starting cells. It is a multi-source BFS, which means multi-source, which means starting cells are multiple. I know all the starting cells are the top cells, so I can start from all the top cells. So I started from all the top cells of this grid. I start from all the top cells, and whichever cell is a land, please push in. Firstly, please push in that cell in my queue and also mark that cell as visited. Now, either you can take another visited array, or you can simply modify your grid back to a water, which means, okay, I can't visit this cell. So I use simply modifying my grid to actually placing a water by just saying, okay, it is visited, and you can't visit that cell. Now, as soon as your starting cells are done, now you can actually start your queue itself, which means starting the standard BFS while not queue is empty. Now, firstly, as you got the queue, as you entered the queue, you will firstly grab the front element and remove that front element. That will give you the row and columns. Now, as you have got the row and columns, you will firstly check, have I reached the bottommost layer? Because ultimately my aim was to start from the topmost layer and reach the bottommost layer. If I have reached the bottommost layer, simply return a true, because it is possible to reach to the bottommost layer. If it is not, simply go and try to do a simple queue, which means simple BFS traversal, going on to all the 4 directions and just see, okay, what is the new R and the new C, which means the new column and the new row. What it is, simply by R plus dx of I, and the dx I have defined above, it is nothing but simply how we do a BFS traversal in the grid. Now, as I've got the new R and the new C, I will check, okay, is it in the bounds of my matrix? I'm checking, okay, is it in the bounds of my matrix? If it is out of bounds, which means if it is less than 0, if it is equal to row, if it is less than 0, if it is equal to column, okay, it's out of bound of the matrix. Or if it is already visited, or if it is a water, both will happen here. If it is already visited, still it's a 1. If it's a water, still it's a 1. Then please continue, because you can't move there. Please continue, you can't move there. If it is not the case, which means if you can visit that, so simply go and visit it, which means mark that cell as visited using a grid itself, marking as 1, which means marking as water, so that you can't visit it again, and simply push that in your queue. Ultimately, the BFS will keep on going, and ultimately try to reach the bottommost cell. If entirely BFS is complete and still it's not able to reach it, so simply return a false in the end. By that, you can just check for that mid, was it possible to actually reach to the bottommost cell or not. If it is possible, then simply go and update your left, which means your range will become a bottommost range, which means the right half of the range. And if it is not possible, then shift your range to the left half of the range, which means right will become a mid -1. And by that, you can simply get your answer. Code is down below. I hope that you guys already see it. Bye bye. It was a very easy question, by the way. Bye.